We come to the next section of mole concept, and here the perspective is to calculate number of particles, but this number of particles are not number of atoms, not number of molecules, but we want to calculate unusual particles like electrons, protons and neutrons. So for that there is an example. Find number of electrons present in 20 molecules of ammonia. If this is a question, if you take nitrogen, it has 7 electrons. If you take hydrogen, it has 1 electrons. So ammonia as a molecule will have how many electrons? Correct, 10 electrons. So 20 molecules will have how many electrons? Cross multiply, that is 20 multiplied by 10, or I can say 10 multiplied by 20. That is what is the number? That is 200 electrons. So total number of electrons are 10 multiplied by 20. By the way, what is 10? 10 is number of electrons present in one molecule. And what is 20? Number of molecules. From this, do we get any formula? Yes. What is the formula? You want to calculate particles like electrons, protons, neutrons, then multiply by F. What does F stand for? You can call it as factor. Whatever number of particles are under interest, those particles in one molecule. We'll call it simple number factor. And what does N stands for? N stands for number of molecules. So if you take number of molecules, multiply by number of particles in that molecule, you will get the required number of particles. Now, do you remember what is the formula for getting number of molecules? Yes, N into Avogadro number. If you don't recall, you remember number of moles is number of molecules upon Avogadro number. So what is the formula for N? N into Na. Now, if you want, N can be written as weight upon molar mass. That is a formula for number of moles. Mass upon molar mass. Or you can write down F, volume of a gas divided by volume of a gas in liter at STP divided by 22.4 multiplied by Na. You remember number of moles given by a formula, volume of gas in liter divided by 22.4. From that we got formula. So what you can remember is number of particles is given by the formula factor multiplied by number of molecules, or more better, factor multiplied by number of moles multiplied by Avogadro number. That formula remains there only. Only number of moles we write down weight upon molar mass, or we write down volume upon 22.4. You know carbon is 612. We are talking about normal carbon. So 12 minus 6, that is 6 neutrons are present. If you take oxygen, 8, 16. 16 minus 8, it has 8 neutrons. So normal elements, normal isotopes will be considered. So one carbon dioxide molecule will have how many electrons? Will have how many electrons? 6 for carbon and 8 for neutrons. If you add, you will get 22 neutrons. That means factor for neutrons is 22. Do you remember a formula for calculating number of neutrons? Yes. What is the formula for calculating particles like protons, neutrons and so on? It is factor multiplied by number of moles multiplied by Avogadro number. Factor is 22. Avogadro number is 6.02, 10 to the power 23. Now the question is how to get moles. For that you should go back to the data. Data given is 2.8 decimeter cube. There is a volume given of a gas but with no information whether it is at STP or non-STP. If no data is given, we'll consider as a STP. So that means they have given volume at STP, then you will divide by 22.4, you will get number of moles. So it is 22 multiplied by volume is how much? 2.8 divided by 22.4 multiplied by 6.02 into 10 to the power 23. Cancel the numbers as much as possible. So 2.8 ones are and 2.8 eights are. This is what you will get. If you simplify, this is 4, this is 3. If you simplify further, then accordingly you will get the numbers 5.5. So approximately it is 5.5 multiplied by 3 into 10 to the power 23. This many number of neutrons will be present. Now many a times, right, algebraic calculations will require faster understanding. 22.4 is a common number. So for your faster calculation, remember multiples of 22.4. If you double it, it is 44.8. If you multiply by 3, it is 67.2. Then also remember, if you divide by 2, it is 11.2. If you divide by 4, it is 5.6. If you divide by 8, actually you're going to divide this number only by 2, so it is 2.8. So remember, 22.4 is some multiple of 2.8, some multiple of 5.6, and so it is 8 times this and 4 times this. Such simple understanding will help you to solve numericals.